So we want now to engage in questions, and for this, remember we are saying it only applies for a system in equilibrium. So we want to do a few questions, 3 questions, so that we can see how to go about such. So some examples. The diagram center below shows a uniform bar balanced about its center by different forces. Calculate the unknown force F2. So this is how the bar looks like. So we can have it here. The pivot at this point here. Then we have several forces acting on it. We have a force of 10 newtons at this point. And we have that's 10 newtons. The distance here we have been given as this distance is 12 centimeters. Then we have another force, 2.5 newtons. The distance from this point here is given as 6 centimeters. We still have another force F2 which we want to determine. So there is a force up here, force F2, and the distance to this point here is 5 centimeters. The distance is 5. So that's the question. We want to go through it. So we are told that the uniform bar is balanced at its center by different forces. You can see we have a force of 10 newtons, 2.5 newtons, and a force F2. So we are told to calculate the unknown force F2. Now we want to approach this question in steps. So the first thing that we need to know which force will produce a clockwise moment and which force will produce an anticlockwise moment. So going by what we discussed in our previous lesson, we can say that this 10 newtons will produce a clockwise moment. So you need to note there we have clockwise moment being produced by that force. So whatever is on this side downward, this one will be anticlockwise. So you just need to note it. Clockwise and clockwise. If we had another force here, we would have anticlockwise. And now this one becomes clockwise. So this one will bring about clockwise moment. So we have clockwise and clockwise. Sorry, this is clockwise and clockwise. This is clockwise. This alone will bring about anticlockwise, not clockwise but anticlockwise. Because if it is alone, it's going to turn it to this direction. So it is anticlockwise. So we have clockwise and clockwise. Clockwise, if we hand any here, then on this side we have anticlockwise. So we want to come and start by stating the principle of moment, because we are told that the bar is balanced. So we'll start by saying that at equilibrium, sum of clockwise moments is equal to sum of anticlockwise moments. So we want to see which moment is clockwise, which one is anticlockwise. So we can see how we have clockwise. So we calculate the moment here, and moment is given by force times the perpendicular distance from the point of support to the line of action. So here we have 10 newtons multiplied by that distance, which is 12 all over 100 to make it in meters. Do we have any other clockwise moment? No, this is anticlockwise, the other one is anticlockwise. So all of this will be equal to the sum of anticlockwise moment. So we have this as our first one. The force is 2.5 newtons and the distance is 6 all over 100 meters. Plus, we have another anticlockwise moment here being given by force F2 multiplied by the distance, which is 5 all over 100 meters. So that is what we have. So we can solve this, we can cancel this by this. So we have 12 over 10, which is 1.2 Newton meters, is equal to, we can multiply this, we have 2.5 multiplied by 6 divided by 100. We end up getting 0.15 and it is Newton meter, plus F2 times 5 over 100 meters. That is 5 over 100, which is 0.05 F2 meters. So that is what we have. So we want to get the value of F2. So we can bring the like terms together. We bring this to the other side such that we have 1.2 Newton meter minus 0.15 Newton meter is equal to 0.05 F2 meters. So that's what we have. So we can subtract 1.2 minus 0.15. We get 1.05. 1.05 Newton meters is equal to 0.05 F2 meters. So remember, we still want to get the value of F2. So we can come and say that 1.05 Newton meters is an equivalent of 0.05 F2 meters. So to get F2, we divide both sides by 0.05 meters by 0.05 meters. This will cancel, meters will cancel, here meters will cancel. So we'll have our F2 being equal to 1.05 divided by 1.05 divided by 0.05. And you end up getting your answer as 21, and it's in newtons. So we can say that our F2 is equal to 21 newtons. Is that okay? So we have been able to get the value of the unknown force F2, and we are able to get it as 21 newtons. So to start with, anytime you are told that the system is balanced, you start by stating the principle of moment just in a short form. At equilibrium, sum of clockwise moments is equal to sum of anticlockwise moments. Then you calculate the clockwise moment, you equate to the anticlockwise moment, and you'll be able to find the value of the unknown. It can be the force or it can also be the distance.